Hello guys, in this lecture we are going to see very important topic of engineering mechanics which is called plane motion. The numerical on plane motion. My dear students, this plane motion is very much important for GATE examination as well as any competitive examination, right? If you consider GATE examination, at least on this topic they have asked 7 to 10 times question, right? Many times they are asking question on plane motion. Now therefore we need to understand first what is the meaning of plane motion, right? And how to solve the plane motion problem, that we are going to see. Here I have written one question on the screen, but my dear students, this is not one question. There are at least 5 to 6 questions in this one question. Means in GATE examination they have asked similar type of questions, right? Also we will see previous year GATE questions also, don't worry about that, right? Let us understand what is the meaning of plane motion. Here I am writing plane motion. Plane motion. See, plane motion is nothing but combination of linear and rotational motion. It is nothing but combination of linear motion plus rotational motion, or we can say circular motion, right? Therefore we need to understand linear motion as well as rotational motion. Now in previous lectures, in one of the previous lecture we have seen linear motion, then in last lecture we have seen circular motion. Now here we will see the both motions together at a time. For example, motion of wheel on ground. Motion of wheel on ground. This is an example of plane motion. So, okay, games. No problem. If you are new, there is no problem. You will understand all the concepts. Don't worry about that. I will take care of that. In every lecture, I am assuming each and every student is new for me, and accordingly, the lectures are going. So you will understand all the concepts. Now, plane motion is nothing but linear motion and rotational motion together. For example, motion of wheel on ground or motion of football on ground. The motion of football on ground. Now, let us consider this is a ground, and on this ground there is a wheel. There is a wheel like this. Now, this is the center of wheel. Let us say there is a center of wheel at A. A is my center of wheel. Now, let us say this wheel is rotating in clockwise direction with angular velocity omega. Here, omega is angular velocity of wheel. Angular velocity rad per second. Omega is angular velocity of wheel in rad per second. मला होस्ट करा की ती डिस्कनेक्ट झालंय आणि होस्टच फक्त शेअर करू शकते वाटते. हा लाईव्ह म्हणजे स्क्रीन शेअरिंग ऑफ झालंय. काय झालं काय माहिती. तुम्ही मला को होस्ट होतो ना, मी मला को होस्ट करा की.
होस्ट करू काय?
हा
कुठून करायचं?
ते पार्टिसिपंट मध्ये जायचं. पार्टिसिपंट मध्ये जायचं, माझ्यावर क्लिक करून करायचं.
पार्टिसिपेंट दोघच आहेत.
हा मग मला को होस्ट करा की, मी त्याशिवाय स्क्रीन शेअर करू शकत नाही.
झालं
Just a minute. Hello. Hello everyone. Sorry for disturbance. Sorry for disturbance. Due to some technical reason प्रॉब्लम आ गया था, तो चलो आप समझते हैं. Now here the wheel is rotating with angular velocity omega on ground, right? Omega is angular velocity in rad per second. Now while rotating, can you imagine this? The wheel of vehicle is moving in forward direction also, right? Means rotation. Angular velocity is nothing but rotation, or we can say it is a circular motion, right? It is a circular motion. Angular velocity means circular motion. And also while rotating, the wheel will move in forward direction. Therefore there is a linear motion also. V is linear velocity in meter per second. Therefore it will be having linear motion also, right? Such type of motion is called plane motion. For example, such type of motion is also called rolling motion. Plane motion is also considered as rolling motion, right? Now let us understand or do the analysis of this motion. Now in previous lecture, that is in circular motion, we have seen relation between linear motion and circular motion. Let us consider for this wheel. If I consider this wheel on ground, let us say this is the initial position of wheel. Here you will find this is the initial position of wheel, right? Here center is at A. The center of wheel is at A, and wheel is rotating in clockwise direction with angular velocity omega. Wheel is rotating in clockwise direction with angular velocity omega. Because of this angular velocity omega, the A this wheel will move in forward direction. That is, it will be having linear motion with velocity v in forward direction, right? After some time, let us consider there is another point B, right? After some time, let us consider there is a point B also on wheel. I am considering point B. After some time, the radius of, let us say radius of wheel is R. Radius of wheel is R is radius of wheel. Radius of wheel, right? Now this center point A will move forward like this. A will go to the another position. Let us say A will go to the A dash. The new position of A is A dash, and the new position of B will here while rotating. See, while rotating, the B is rotating like this, right, in clockwise direction. Therefore, the new position of B will be by rotating. Good evening, Mandeep Singh. Good evening. Now, the new position of B will be somewhere here. Let us say the new position of B is B dash here. B dash means from AB location to it is reached to A dash B dash. Therefore, it has turned angular displacement also theta. The wheel has turned the angular displacement theta also, right? As well as from A, this A point is moved from A to A dash. Therefore, this is a linear displacement of A. From A to A dash, we can say it is a linear displacement of, right? A to A dash is linear displacement of A, that is SA, right? Now, the relation between A is center. My dear students, A is center of wheel, and these relations holds good for center of wheel, right? The linear displacement of A, SA, is equal to, okay, I will increase the font. The linear displacement of A is given by R theta. This is linear displacement of center point, right? That we have already learned, right? The linear displacement of A is R theta, as well as linear velocity of A point, that is linear velocity of center point, is R omega, radius of wheel into angular velocity. Linear velocity of A is radius of wheel into angular velocity. And linear acceleration of A is r alpha, radius of wheel into angular acceleration. This wheel is moving with angular velocity omega, then there will be an angular acceleration alpha also. Alpha is angular acceleration. Angular acceleration in rad per second square. And A is linear acceleration of A. Linear acceleration in meter per second square. Right. These are the relations for center point. Therefore, for center point of wheel, the linear displacement of center point is radius of wheel into angular displacement. The linear velocity of center of wheel is radius of wheel into angular velocity. The linear acceleration of center point of wheel is radius of wheel into angular acceleration. These are the very important results for center point only. Right. Now, but with center point, but with center of wheel, can you say other points are also rotating? As center of wheel is rotating, with this point center, total points on the wheel are also moving. All the points are having motion. Now, for such type of motion, we can find velocity as well as acceleration for each and every point lying on the wheel. Now that is our target, and at least 10 to 12 times they have asked this question on in gate examination. Now we will go to find for any other point. Let us consider again here, same we have calculated the linear velocity. These are the formulas, that is displacement of A is equal to r theta. R is radius of wheel. Velocity of A is r omega, and acceleration of A is r alpha. And where A point is center point. A is center of wheel. Right. Center of wheel. Right. And R is radius of wheel. Radius of wheel. Right. Games without understanding of concept, we cannot solve the problem. Right. You'll learn many concepts. First understand the concept, then you can find velocity and acceleration for infinite points. Provide me any point, you can find quickly. Try to understand the concept so that you will get full marks in gate examination, because this is very much important for gate examination. Many times they are asking. Right. Now let us consider, if I consider one link, let's say there is a point and there is a B point on the link. Right. And distance between A and B is RAB. Distance between A and B is RAB. Right. Now, let us say this link is having linear motion as well as circular motion. The link is under circular motion. Let us say the link is moving with angular velocity omega. Right. And angular acceleration alpha. And angular acceleration alpha. Now, after some time, the A point will go forward like this. There will be a linear. If I consider linear motion, the wheel will go like this. Here I have considered only linear motion, that is A dash, and here B dash. Now A dash, B dash, it is only linear motion. Therefore, let us say this is displacement of A. Right, this is displacement of A with some velocity of A, with some acceleration of A. This is only linear motion. We can say this portion is only linear motion of A. Linear motion, straight line motion hai ki nahi? This is only linear motion. Now with linear motion there is circular motion also. Therefore, along with linear motion, circular motion will add like this. Let us say after some time the wheel has reached a new location. Let us say B double dash. And now B double dash is the final position of B. A double dash is the final position of A. B double dash is the final position of B. And let us say there is an angular displacement theta. Let us say there is an angular displacement theta. Theta is angular displacement. Therefore, there will be an angular motion also. Now, from B dash to B double dash, can I say from B dash to B double dash, we will get extra motion for B with respect to A. Right. Here, yes, SA, VA, AA. We have considered velocity, acceleration, and displacement of A point. But with respect to A, B has covered some extra displacement with extra velocity and acceleration. These components also we have to add, my dear students. Therefore, this component is rotational motion. Here you can see this portion of motion is circular motion. Circular motion of B with respect to A. Right. Circular motion of B with respect to A. Therefore, here in this portion, the displacement is displacement of B with respect to A. Velocity is velocity of B with respect to A. Acceleration is acceleration of B with respect to A. Here it is this, yes, BA means displacement of point B with respect to point A. VBA means velocity of point B with respect to A, and ABA means acceleration of point B with respect to A. This component we are getting extra. Therefore, we can say here, and here the radius of link. Here the radius of link is RAB. RAB. Right. And angular displacement is theta. Angular displacement is theta. Now here, therefore, we can say the final displacement of B is, here we can see this is the final displacement of B, that is displacement of B with some final velocity of B with some final acceleration of B. Simply we can say final position we have to consider for B. Therefore, this is a displacement of, this much is a displacement of B with velocity of B, acceleration of B. Now this displacement of B is nothing but we can say displacement of A as it is. You can see here displacement of A as it is plus displacement of B with respect to A. Therefore, displacement of B is equal to displacement of A plus displacement of B with respect to A. Right. Therefore, displacement of B is equal to displacement of A plus. Now, this displacement of B with respect to A is a circular motion. Here it is a portion of circular motion. Right. You can see displacement of B with respect to A is a circular motion, and for circular motion, displacement is r theta, that is radius AB. We have to consider radius AB means distance AB into theta. This is displacement of B with respect to A. Right. Again, if I want to find velocity of B point, here we can see velocity of B point. Here, velocity of A will remain as it is. See, velocity of A will remain as it is, plus velocity of B with respect to A will get added. Therefore, it is velocity of A plus velocity of B with respect to A. Velocity of B with respect to A. Right. And for, and here velocity of B with respect to A is under circular motion. Therefore, here velocity of B will be equal to velocity of A plus circular motion के लिए क्या होता है? Radius of that component RAB into angular velocity omega. It is radius of wheel RAB into angular velocity omega. Right. Now let us find acceleration. Now, if I find acceleration, let us write acceleration of B point. Acceleration of B will be equal to, again we can say acceleration of B is acceleration of A plus acceleration of B with respect to A. Acceleration of A plus acceleration of B with respect to A. And my dear students, in case of circular motion, here acceleration of B with respect to A, this is a circular motion, this part is a circular motion. And in case of circular motion, we have seen there are two accelerations. That is acceleration of B with respect to A is nothing but we have two accelerations, that is tangential acceleration plus centripetal acceleration. For circular motion, there are two accelerations. There is tangential acceleration and centripetal acceleration that we have learned in previous lecture. इसके ऊपर मैंने 1.5 घंटे का लेक्चर लिया है इससे पहले के वीडियो में, लाइव लेक्चर में, राइट, वो आपको आना चाहिए. नाउ therefore this tangential acceleration is nothing but the formula for tangential acceleration is RAB alpha. This also we have taken derivation देखा है previous lecture में, हमने इसका derivation भी देखा है. Tangential acceleration at B is RAB alpha and it is in tangential direction, in tangential direction, right. And centripetal acceleration is AC is RAB omega square. Centripetal acceleration is RAB omega square, right? It is towards center along radius, towards center along radius, that we have learned in previous lecture. इसके ऊपर हमने क्वेश्चन भी ले लिए हैं, right? Now let us go for the, and my dear students, we must remember displacement is a vector quantity, velocity is a vector quantity, acceleration is a vector quantity. All are vector quantities. Therefore there must be a vector addition. There must be a vector addition of all them. There must be a vector addition of all them. Vector addition is nothing but, let us say there is a one vector a and other vector, this is a vector a and there is a vector b, there is a vector b, and angle between vector a and b is theta. Then if I want to find resultant vector, which is nothing but vector a plus vector b, then the formula for this resultant will be equal to under root of a square plus b square plus twice ab cos theta, and this resultant vector lies in between these two vectors. This is the direction of resultant vector that we have seen in law of parallelogram. While solving the first lecture of engineering mechanics, the first live lecture of engineering mechanics, in this I have taken numericals on law of parallelogram. Now as per this law we have to do additions, right? Now after this let us go to the numericals. Let us go to the numericals, right? Here we are going to solve the question. The question is on your screen. Here you may see that it is only one question, but there are 10 to 15 questions in this single question. At least 10 to 15 questions will be covered in this single question. Right. Now, okay, let us go to the question. A wheel, question is a wheel of radius 2 meter. Here radius of wheel is given, my dear students. Radius of wheel is given 2 meter. A wheel radius 2 meter rolls freely as shown in figure. Now here the wheel is rotating in clockwise direction with angular velocity omega. The wheel is rotating in clockwise direction with angular velocity omega, right? Now angular velocity is clockwise rotation. Now if the velocity of point A is 6 meter, can you imagine, can you see here, A point is the center of wheel. A point is the center of wheel. Here you will find A point, which is nothing but center of wheel. Therefore velocity of center point is given 6 meter per second. Now then the find velocity of various points on wheel. Now various points are shown, that is point B, point C, point D, point E, point P, point R, and you can consider any other point. You can consider infinite points on this wheel, and you can find velocity of these infinite points, right? With simple way also. There are two methods to find these velocities. We will see both methods because both methods are very much useful for competitive exams, right? And after finding velocities, we will see finding of acceleration for each and every point, infinite points on this wheel, right? Very famous question for competitive exams. Now let us first understand for velocities, right? Then we will understand for accelerations. Then understanding of acceleration is very simple. Now my dear students, here angle at A, that is angle PAB, that is angle PAB is given 30 degree, and distance of A to R is given 1 meter, and we have to find velocity for each and every point. Here 6 points are given. Now velocity of A, that is velocity of center point, is nothing but radius of wheel into angular velocity, that we have learned already in previous lectures, right? Therefore we can say angular velocity of wheel is equal to VA divided by R, which is nothing but velocity of A is 6, radius is 2, which is nothing but 3 rad per second, right? 3 rad per second is the angular velocity of wheel, right? Now we have calculated angular velocity of wheel is equal to 3 rad per second, which is very much important, right? And radius of wheel is 2 meter. Radius of wheel is given 2 meter. My dear students, can you see the diagram? In diagram they are asking velocity of other points. Now let us draw this diagram once again, and we are going to find velocity of each and every point, right? Now the diagram is clearly visible. I think the diagram is clearly visible to everyone, right? Now I am going to erase the question. I am going to erase the question so that I am keeping only diagram here. Okay. Then then here we are going to find velocity one by one for each and every point, right? Now we have calculated. First thing, we have calculated that angular velocity, that is velocity of A, is given 6 meter per second. Radius of wheel is 2 meter. Angular velocity of wheel is 3 rad per second. This is very much useful data, right? Now let us go for point B. Now first of all, we will calculate velocity of point B. Focus on point B. My dear students, can you imagine here distance between A to B, distance between A to C, distance between A to D, distance between A to E, and A to P is same. That is, can you say here distance between A to B, radius of AB is equal to radius of AC is equal to distance between A to D is equal to distance between A to E is equal to distance between A to P. All distances are same. Here all distances are same, right? Which is nothing but which is nothing but radius of wheel, which is nothing but radius of wheel, which is nothing but 2 meter. Therefore, the respective velocity components, that is velocity of point B with respect to A, which is nothing but RAB omega. Velocity of point C with respect to A is nothing but RAC omega. Similarly, velocity of point D with respect to A is nothing but RAD omega. Similarly, velocity of point E with respect to A is nothing but RAE omega. Similarly, velocity of point P with respect to A is nothing but RAP omega. Therefore, these respective velocity components will be same. The magnitude will be same. Therefore, we can say here velocity of point B with respect to A is equal to velocity of point C with respect to A is equal to velocity of point D with respect to A is equal to velocity of point E with respect to A is equal to velocity of point P with respect to A is equal to radius of wheel into omega, because RAB is equal to RAC is equal to RAD is equal to RAE is equal to RAP is equal to radius of wheel, which is nothing but 2 meter. That we can clearly see here. Therefore, these all components will be equal to radius of wheel is 2, radius and angular velocity is 3. Just we have calculated, right? Radius of wheel is 2 and angular velocity is 3. Therefore, these components will be equal to 6 meter per second, right? These are respective velocities, my dear student. These are respective velocities, right? So here I am again making one note. Here I am again making one note. These components I am going to write here, right? And after that we will find for point B. Now put this data here. Now velocity of point B with respect to A is equal to velocity of point C with respect to A is equal to velocity of point D with respect to A is equal to velocity of E with respect to A is equal to velocity of P with respect to A is equal to 6 meter per second. That means we can conclude here each and every point on the circumference will be having same velocity of that point with respect to center. For circumference, all the points are equated at same distance from center. Therefore, the respective component will be 6 meter per second on circumference only. Right. Now, let us concentrate on point B. We are going to find velocity of point B. Here, my dear students, we have not calculated velocity of point B. Only we have velocity of point A and velocity of point B with respect to A. But we don't have magnitude for velocity of point B. Right. Final velocity of point B. Now let us concentrate on point B. Point B. Right. We can say velocity of point B is equal to velocity of A plus velocity of B with respect to A. This derivation we have done, but this is a vector addition. सीधा सीधा एडिशन मत करना, वेक्टर एडिशन नहीं है, this is a vector addition, right? As per law of parallelogram, right? Now focus on point B. Now this is a wheel. Here this is your wheel, right? Here center A, right? As wheel is moving in clockwise direction, definitely because of this clockwise motion, the wheel will go forward. That is velocity of A will go towards right side. Therefore, for this wheel, here there is a B point, right? Now this A point is going towards right with velocity of A. Now, can you see here? For B also, velocity of A, that is velocity of center, will remain as it is. Therefore, at B, velocity of A will remain as it is, which is nothing but 6 meter per second. The center velocity will always remain as it is, right? But because of this clockwise rotation, here the rotation of wheel is clockwise with angular velocity omega, right? Because of this clockwise rotation with angular velocity omega, can you can you able to imagine this point B while rotating in clockwise direction is going downward? While rotating in clockwise direction, this point B will go downward with respect to A. नीचे नीचे आएगा ना इसे, like this. The B will change its location like this. It will move in downward direction with respect to A, right? Therefore, and with respect to A, components are tangential. Therefore, the velocity of B with respect to A will be tangential to the circle at in downward direction like this. This is velocity of B with respect to A, which is nothing but 6 meter per second, which is nothing but 6 meter per second in downward direction, right? Therefore, here there is a B point, right? Now we have understood the directions of velocities. That is, velocity of A will be towards right, velocity of B with respect to A will be downward, that is 6 meter per second, right? Now we have to find resultant of these two, because it is a velocity of B with respect to A and it is a velocity of center point only, right? And we have to find resultant of these two components. Therefore, the resultant of these two components will lie in between them. The resultant will lie in between them like this. This will be the velocity of B, which is nothing but as per law of parallelogram. We have to add them as per law of parallelogram. Now, अब दो परपेंडिकुलर वेक्टर का लॉ ऑफ पैरेललोग्राम क्या होता है? पाइथागोरस थ्योरम. For two perpendicular vectors, the law of parallelogram will become Pythagoras theorem. That is under root of, we can say, VA square plus velocity of B with respect to A square. This is vector addition. This is the vector addition. That is law of parallelogram, right? We have seen this. Now is equal to, therefore, under root of 6 square plus 6 square, which will be equal to 6 root 2 meter per second. And the direction is this. Therefore, if question is to find velocity of B, then velocity of B is this direction. You can see velocity of B is this direction with magnitude 6 root 2 meter per second. 6 root 2 meter per second. Right. This is very important, my dear students. Now, once you have calculated velocity of B, let us go for velocity of C. Finding velocity of C. I hope this is clear. Now, understanding of velocity of C is then will be simple. If anybody having doubt to calculate velocity of B, tell me, because we are going to calculate velocity of C, D, E, P and R. There are many points. यहां तक किसी को डाउट है तो इमीडिएट पूछो मुझसे, क्योंकि इसको मैं इरेज करने जा रहा हूं एंड वेलोसिटी ऑफ सी को निकालने जा रहा हूं मैं यहां पे. अप टू दिस पॉइंट इफ नो डाउट, लेट अस मूव फॉरवर्ड. आगे बढ़ते हैं फिर. नोट डाउन दिस क्विकली. नोट डाउन इन 1 minute 30 seconds, sorry. And if anybody having doubt, tell me. If this is clear, each and every point properly you will understand. If this is clear, there is no any problem or any doubt to understand other points. Okay, I am going to erase this and we are going to solve for point C. Let us find velocity of point C. Now, here, this is a wheel. You can see this is a wheel having center at A. A is the center of wheel, and here it is a at the ground. There is C point. C point is a point of contact between ground and wheel. Point C, we can say point C is point of contact between wheel and ground, right? Now A point is moving towards right with velocity of A, which is nothing but 6 meter per second, right? And velocity of C is nothing but velocity of A plus velocity of C with respect to A. Velocity of C is nothing but velocity of A plus velocity of C with respect to A, right? And velocity of C with respect to A is a tangential component. Velocity of C with respect to A is a tangential component. Now let us see this. Therefore, for C point also, the velocity of A will remain as it is, and there is one more tangential component, right? Therefore, here we can say the velocity of A will remain as it is for C also, which is about 6 meter per second towards right, and the wheel is rotating in clockwise direction with angular velocity omega. The wheel is rotating in clockwise direction with angular velocity omega. Therefore, can you imagine here this point C will go in back towards left. देखो पीछे पीछे जा रहा है कि नहीं with respect to A. The C is moving in backward direction, that is towards left. You can imagine here, right? Like this, like this. C is moving with respect to A with angular velocity. Therefore, at this C point, there will be a tangential component, and a tangential component is always perpendicular to radius. That is, this is RAC. From RAC, A to C distance, and perpendicular to this RAC, right? Therefore, perpendicular to RAC going backward direction, there will be a velocity of C with respect to A, which is nothing but 6 meter per second. Which is nothing but 6 meter per second. Right. Now, our target is to find velocity of C. Now, can I say velocity of C is equal to, it is a vector addition, velocity of A plus velocity of C with respect to A, vector addition. Now, अब clearly देखो यहाँ पे, the velocity of A is going towards right, velocity of C is going towards left. Now, for them inline forces, there is a direct addition. If direction is opposite, one is positive, other is negative. Right side will be positive, left side will be negative. Therefore, it is plus 6 minus 6, which is nothing but 0. They will cancel each other or not. This 6 meter per second will cancel this 6 meter per second. 6 meter per second going towards right side will cancel 6 meter per second going towards left. Therefore, the velocity of point C will be 0. This is very much important conclusion. Velocity of C is 0, right? This is very much important conclusion, my dear students, right? Now, the point of contact between wheel and ground will be having 0 velocity, and such point is called instant center in theory of machine for mechanical student. And if there are civil students, then understand this point. The point which is having 0 velocity in the given configuration is called instantaneous center. This is a C is instantaneous center or instant center of rotation. Instant center of rotation. Now, what is the significance of this instant center? Because it is having great significance after solving this question. Now, by concept of instant center also, I'm going to solve this similar question, and with the concept of instant center, the same question can be solved in 15 to 20 seconds only, right? Now, here we have proved that the velocity of C is 0, right? Therefore, the significance of instant center I am going to explain you, right? Now, in such case, the point of contact between wheel and ground is nothing but C, and the velocity of this point is 0. This is called instant center. Instant center. And instant center is nothing but about this point, plane motion problem can be treated as pure rotation problem about instant center C, right? Now, अब डेफिनेशन बहुत लोगों को हजम नहीं आई होगी, क्या लिखा है, व्हाट इज द मीनिंग ऑफ दिस डेफिनेशन, that we are going to see in, that we will understand in numerical, right? Don't worry about that. Here the question is of plane motion, that is the wheel is having circular motion as well as linear motion. While rotating, the wheel is going in forward direction, right? And then we are doing analysis for linear component, linear motion as well as circular motion, right? Now if my assumption is that wheel is rotating about instant center, then there is no linear component, there is only circular component. This is the meaning of this definition that I will explain in problem only. Let us find first velocity of all the points. And as of now, remember, C is the instant center. And at the last of lecture, in just 2 minutes, I will find all the velocities of each and every point on the wheel in just 2 minutes. सारे पॉइंट की वेलोसिटी 2 ही मिनट में निकालेंगे, मतलब एक पॉइंट की वेलोसिटी हम 15 सेकंड में निकालेंगे एट द एंड ऑफ लेक्चर विद द कंसेप्ट ऑफ इंस्टेंट सेंटर. एज ऑफ नाउ रिमेंबर सी इज द इंस्टेंट सेंटर, राइट? now let us go for velocity of D, right? We are going to see velocity of point D. Now here wheel is rotating, there is a wheel like this, and the center of wheel is at A. This is the ground. The center of wheel is A, which is going towards right, with velocity of A is nothing but 6 meter per second. With velocity of A is 6 meter per second. Now with respect to A, D point is at this location, there will be a D point. Now this D point will be having same velocity. Now velocity of D is nothing but velocity of A plus velocity of D with respect to A, and this is a vector addition. This is a vector addition, right? Now this wheel is will be having, this wheel will be having for a D point, velocity of A will remain as it is, right? Therefore let us draw here velocity of A for the wheel, right? Therefore this will be for a D, there will be a velocity of A will remain as it is, which is nothing but 6 meter per second, which is nothing but 6 meter per second. As well as the wheel is rotating in clockwise direction like this with angular velocity omega. Wheel is rotating in clockwise direction with angular velocity omega. Therefore with respect to A, can you imagine this point will, D point will go in upward direction. देखो A के रिस्पेक्ट में D पॉइंट ऊपर भी जाने की कोशिश कर रहा है ना, as rotating A, D is moving in upward direction, right? Therefore there will be a tangential velocity which is perpendicular to radius. Therefore there will be a tangential velocity which will go in upward direction like this, perpendicular to radius, which is velocity of D with respect to A. This is also 6, we have calculated. Now velocity of A is 6, velocity of D with respect to A is 6, and angle between them is 90 degree. For resultant of them is lie between them, दोनों का resultant दोनों के बीच में रहेगा. This will be the resultant velocity of point D, which is nothing but here vector addition as per the law of parallelogram, and for two perpendicular vectors the law of parallelogram becomes Pythagoras theorem, which is nothing but under root of VA square plus velocity of D with respect to A square, right? Therefore put these values, therefore velocity of D will be equal to, that is velocity of D will be equal to under root of 6 square plus 6 square, which is nothing but velocity of D will be equal to 6 root 2 meter per second, right? This is the magnitude of velocity of point D. This is the final velocity of D. Velocity of D is 6 root 2 meter per second, and direction is shown here. Direction is shown here, right? Now after this let us go for point E. देखो दोस्तों साइड में लिखते चलो, सारे पॉइंट्स की वेलोसिटी साइड में लिखते चलो, क्योंकि बाद में हमें प्रूव करना है with the concepts of instant center. सब सारे आंसर सेम ही आने चाहिए, राइट? नाउ आफ्टर दिस लेट अस गो फॉर पॉइंट ई. अगर किसी का सॉल्व, किसी को कभी भी डाउट आता है यहां तक, इफ एनीबॉडी फीलिंग एनी डाउट यू कैन आस्क मी. फॉर एनी डाउट प्लीज आस्क मी. आई एम गोइंग टू इरेज दिस velocity of D. Let us go for velocity of E. Let us go for velocity of point E, right? Now see there is a wheel, there is a wheel like this, and there is a center at A which is moving towards right with velocity of A which is on the 6 meter per second, and A के रिस्पेक्ट में with respect to A There is a E point here. There is a E point here. Therefore, velocity of E is nothing but velocity of A vector addition. Velocity of E is velocity of A plus velocity of point E with respect to point A, vector addition, right? Means velocity of A will remain as it is to the E. This is velocity of A, which is nothing but 6, and wheel is rotating in clockwise direction with angular velocity omega. Wheel is rotating in clockwise direction with angular velocity omega, right? Therefore, can you see here? This point E will move towards right with respect to A because of this angular velocity. The point E will go downward, downward, downward like this. Downward, 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 downward. Means while going downward, it is going towards right or not, right? Therefore, at E, at this instant E, there will be a velocity of E with respect to there will be a velocity of E with respect to A tangential at this location, like this. There will be a velocity of E with respect to A, which is nothing but 6 meter per second, right? Hello, Vatsalya. Okay. Now, can you see here? Velocity of A is going towards right. Velocity of E with respect to A is also going towards right. Therefore, they will directly get added. एक ही डायरेक्शन में है तो डायरेक्टली ऐड करना होगा ना. Therefore, velocity of E is equal to 6 plus 6, which is nothing but 12 meter per second. Which is nothing but 12 meter per second. Right. Now, up to now, we have calculated for 4 points. Up to now, we have calculated for A, B, sorry, B, C, D, and E. Let us go for point P. Let us go for point P. Right. Here I am erasing for point E. Let us go for point P. Now again, here you will see this velocity. This is a wheel. Here you will see this is a wheel. For this wheel, A is the center, which is moving. A is the center, which is moving with velocity of A, 6 meter per second towards right. Towards right. Right. Now, and point P is somewhere here. Point P is somewhere here. Right. Therefore, point P will also be, this velocity of P will be equal to vector sum velocity of A plus velocity of P with respect to A, vector addition. Right. Now, angle is 30 degree. This angle is 30 degree. Let us say this angle is theta. Any angle. यहाँ पे तो मैंने 30 degree दे रखा है. But in examination, they will provide you any angle, whatever may be the angle. Right. Now, this velocity of A will remain as it is for P. So, there is velocity of A as it is for P also, which is about 6 meter per second. And there is tangential velocity, and this wheel is rotating in clockwise direction like this. With angular velocity omega, the wheel is rotating in clockwise direction. Therefore, can you imagine with respect to A, the point P will go downward, slowly moving in downward direction like this, right? Therefore, there will be a tangential component at P which will go in downward direction. Tangential component is perpendicular to the radius. That is, it is perpendicular to RAP, right? So draw perpendicular to RAP like this. There will be a velocity of P with respect to A, which is perpendicular to RAP, perpendicular to this, right? Therefore, if I extend this RAP, here there will be angle theta, right? Here already given with horizontal, the angle of AP line is theta here. The same angle will remain here. Therefore, here this angle will be, can we say 90 minus theta? This angle will be 90 minus theta. 100%. This angle will be 90 minus theta. Right. Now, therefore, this velocity of A, P with respect to A is 6 again. Now, angle between them is, here angle between VA and VPA is 90 minus theta. Right. And the resultant of them will be in between them. इन दोनों के बीच में रिजल्टेंट ऑफ वेलोसिटी P रहेगा. The velocity of P will be in between them. इन दोनों के बीच में रहेगा. Means we can say here there is a at point P. See, at point P there is a VA of 6 meter per second. velocity of p with respect to a of 6 meter per second, and this angle is 90 minus theta. Theta is 30 degree. Therefore, 90 minus theta will be 60 degree. Therefore, this angle will be 60 degree, my dear students. This angle will be 60 degree. Angle between velocity of a and velocity of p with respect to a will be 60 degree, because theta is given 30 degree, and the resultant of them will be line in between them. That is velocity of p. This is the velocity of p, and add them as per law of parallelogram. Now we have to add them with the help of law of parallelogram. Let us add them. Then let us add them with the help of law of parallelogram. Right. We are going to use here law of parallelogram. Velocity of use law of parallelogram. Velocity of p with respect to a is 6. Angle between them, can we say here this is a velocity of 6, and here 6, and angle is 60 degree. So resultant will be here, resultant is velocity of p. Add them with the help of law of parallelogram. It says that velocity of p will be equal to under root of 6 square plus 6 square plus twice into 6 into 6 into cos 60. Angle between them is 60. Angle between them is 60 degree into cos 60. This is a law of parallelogram or not? That is, the law of parallelogram becomes, if I write total law of parallelogram, velocity of p will be equal to under root of velocity of a square plus velocity of p with respect to a square plus अंडर रूट में ही है ये सब कुछ, इन अंडर रूट twice velocity of a, velocity of p with respect to a, cos of angle between them, which is nothing but theta. Sorry, 90 minus theta here. Angle between them is 90 minus theta. Angle between them is 90 minus theta. My dear students, angle between velocity of a and velocity of p with respect to a is 90 minus theta. Therefore, velocity of p will become equal to under root of 6 square plus 6 square plus 2 into 6 into 6 into cos 60. Cos 60. And cos 60 कितना होता है? What is cos 60? 1 by 2. Cos 60 is 1 by 2 or not? Right. Cos 60 is 1 by 2. Therefore, this cos 60 and 2 and cos 60 will get cancelled each other. एक दूसरे को cancel कर देंगे ना. Cos 60 is 1 by 2 into 2. 1. Therefore, the answer will be velocity of p will be equal to under root of 6 square plus 6 square plus 6 square, which is the velocity of p is equal to 6 root 3 meter per second. Velocity of p will be 6 root 3 meter per second. This is your answer for velocity of p point. Right. कोई डाउट होगा तो इमीडिएट पूछो. If any doubt, ask me immediately. Right. Let us go for point R. अब सर्कमफ्रेंस पे तो पॉइंट देखिए, सर्कमफ्रेंस के अंदर पॉइंट होगा तो क्या करेंगे? If the point is lying inside the wheel, on circumference we have calculated. For any angle theta we have calculated, as well as for 90 degree in line and opposite line we have calculated. But if the point is lying inside the wheel, what will happen? Right. Let us find for point R. Here I am going to find for point R. Now, point R. My dear students, point R, see, this is a wheel. Here you can see this is a wheel. Right. A point is center, which is moving with velocity of A, which is about 6 meter per second towards right. And point R is somewhere here. Point R is in between the wheel. Right. Now, the velocity of A will remain as it is for point R also. That is, velocity of R will be equal to velocity of A plus velocity of R with respect to A. Therefore, for R point also, velocity of A will remain as it is, which is nothing but 6 meter per second. Now, velocity of R with respect to A will be equal to radius of distance between A and R into omega. We have to consider distance between A and R ना, क्योंकि R का देख रहे हैं हम, तो R and A के बीच में कई डिस्टेंस लेना है, and this distance between R and A is given 1 meter. Given data देख लो, in given data this distance is given 1 meter. Therefore velocity of R with respect to A will be equal to 1 into 3. Angular velocity is 3. Angular velocity is already given, which is 3 rad per second, right? Therefore this will become velocity of R with respect to A is 3 meter per second. अब डायरेक्शन को समझ लो. Now this wheel is moving in clockwise direction with angular velocity omega. Therefore definitely this R will go in downward backward direction at different radius. See, the R is rotating at this radius, 1 meter radius. The point R is rotating at 1 meter radius. Correct or wrong? The point R is rotating at 1 meter radius. Therefore this R will go in down backward direction like this. Anti-clockwise moment के लिए velocity of R with respect to A will be backward, which is nothing but 3. Therefore if I check R point, this is R point is moving with velocity of A towards right with 6 meter per second, as well as moving with velocity of R with respect to A with 3 meter per second towards left, right? Therefore can I say the resultant velocity of R will be equal to 6 minus 3. Inline है ना, inline but in opposite nature. One is going towards right, one is going towards left. Therefore there will be a subtraction, right, which is nothing but 3 meter per second towards right. This will be the direction. Direction will be towards right, the direction of larger vector. It will attain the direction of larger vector. Now up to this, if anybody having any doubt, you can ask me, right? And if no doubt, I am giving you 20 seconds, maximum 20 seconds, think over this. If anybody having doubt, ask me. अगर doubt नहीं है, then we are going for another method. This is a conventional, ये जो देखा हमने conventional method था. In next method we will see by the use of instant center how to solve this problem. By the use of instant center method, how to solve this problem, that we are going to see. If anybody having doubt up to this, tell me. If no doubt, we will go for instant center method. I am waiting for 20 minutes for your 20 seconds for your doubts, or 30 seconds for your doubts. If no doubt, let us jump on instant center method. I hope किसी को doubt नहीं है. Nobody is having doubt. So let us solve this question with the help of instant center. Instant center is nothing but the point where velocity is 0. Instant center is the point of 0 velocity, and we have calculated the velocity is 0 for such case for point C. Point C, which is nothing but point of contact between wheel and ground. For point of contact between wheel and ground, there is a 0 velocity that we have seen, right? Therefore point C is the instant center. Now what is the significance of instant center there, that we are going to see, and how to solve this problem with the help of instant center, that we are going to see. Now everybody is known about the points. Let us go for instant center. Here, let us say I am drawing the wheel. Let us say this is a wheel, right? Now this is a wheel. On this wheel, there is a point A, which is center of wheel. right? Then point B, right extreme point is point B. The bottom point, south extreme point is a point C, and this point C is also point of contact between wheel and ground, right? Then left extreme point we have taken as point D. The top extreme point is point E, right? नाउ अब डायग्राम बहुत कॉम्प्लिकेटेड हो जाएगा, इसलिए पहले इन तीन नाउ सो लेट अस कंसीडर फॉर दिस 4 पॉइंट्स फर्स्ट, राइट? इंस्टेंट सेंटर बेटा 5 मिनट में खत्म होगा, दैट कंसेप्ट विल टेक ओनली 5 मिनट्स. थोड़ा 5 मिनट के लिए आपको कॉन्सेंट्रेट करना है अभी. क्रेजी चेरी, कॉन्सेंट्रेट फॉर 5 मिनट्स ओनली. वेरी इंपॉर्टेंट कंसेप्ट, बिकॉज नेक्स्ट क्लास में ये थोड़ी ना मैं रिपीट करने वाला हूँ. न्यू कंसेप्ट स्टार्ट करूंगा ना, न्यू कंसेप्ट पे न्यूमेरिकल लेंगे, राइट? नाउ कंटिन्यू करना है या नहीं अदर स्टूडेंट्स? Other students, tell me your opinion. किसी का कोई रिप्लाई नहीं आता है तो मैं कंटिन्यू करने जा रहा हूं. अगर आपको स्टॉप करना है तब स्टॉप करेंगे, किसी का अगर कमेंट आता है तो. अदरवाइज वी आर गोइंग टू कंटिन्यू, राइट? नाउ वी हैव सीन दैट वेलोसिटी ऑफ c is 0, therefore c is instant center, which is also called IC. Therefore c is instant center, right? Now this plane motion problem, here the wheel was having angular motion, the wheel was rotating with angular velocity omega, that is 3 rad per second in clockwise direction, as well as moving in forward direction with velocity of a, right? Center velocity, that is velocity of a. Now here what I will assume, the wheel is under pure rotation only, there is no linear motion. What, see my dear student, this angular velocity 3 rad per second and linear velocity of center point is 6, which is towards right. This is for plane motion with respect to a. ये सब कुछ था with respect to center point, that is a point. But what I am assuming about this instant center C, the wheel is only having angular motion which is only but with 3 rad per second. About this instant center C, the wheel is having angular motion which is with 3 rad per second. Let us say it is 3 rad per second. Angular velocity is here. The point C is having instant center. Therefore, I am fixing this C. Here C is my instant center and wheel is rotating in clockwise direction with angular velocity about C. This is my assumption. This is not the reality. With 3 rad per second, this is not the reality, right? Now for circular motion, velocity is equal to r omega, right? For circular motion, velocity equal to r omega, and here velocity is perpendicular to radius, that already we know. Velocity is perpendicular to radius and it is equal to r omega, that already we know. Now let us find radius of wheel is here. Distances are a to c is 2 meter, right? A to c is, this distance is 2 meter. A to E again 2 meter. A to B 2 meter and A to D 2 meter, right? These are the distances, right? That we know, right? Now let us consider point A. If I want to find velocity of point A, this will be perpendicular to AC, right? That is radius of A will be RAC. Here blue color से दिखाने जा रहा हूं मैं, like this. This blue color is a radius of A, that is RA, which is nothing but 2, and perpendicular to this, the wheel is rotating in clockwise direction, right? Therefore A point for clockwise rotation, A point, can you imagine here, will go towards right. Therefore this velocity of A will be perpendicular to RA. This will be the velocity of A. Velocity of A, which is nothing but R A omega. And R A is 2, omega is 3. Therefore, we can say velocity of A will be equal to 2 into 3, which is nothing but 6 meter per second. Perpendicular to radius, right? Perpendicular radius. There must be a 90-degree angle between them, right? ये हो गया A point का. Let's concentrate on B point. Now, distance of B from C. This distance of B from C. You can see this. This is the distance of B from C, which is nothing but radius of B. Which is nothing but radius of B. And can I say radius of B will be equal to, see, look at the triangle CAB. Triangle CAB. As per Pythagoras theorem, RAB will be equal to under root 2 square plus 2 square, which is nothing but 2 root 2. Right? Which is nothing but 2 root 2. And wheel is rotating in clockwise direction with angular velocity omega. Therefore, perpendicular to this RB, perpendicular to this RB and rotating in clockwise direction means B will go downward. For clockwise rotation, B will go downward. Therefore, this will be the velocity of B, which is RB omega, which is RB omega. Therefore, velocity of B will be RB is 2 root 2 into angular velocity 3, which is nothing but 6 root 2, which is nothing but 6 root 2 meter per second. 6 root 2 meter per second. Correct. Perpendicular radius. There must be a 90-degree angle. यही तो आंसर आया था, यही तो डायरेक्शन आया था. Right. Let us go for C point. Let us go for C point then. After calculation of this, let us go for C point. Right. Now see the distance of C from C. Radius of C is 0. That is distance of C point from the C point is 0. Therefore, velocity of C will be RC omega, which is 0. Right. Let us go for D point. Let us go for D point. The radius of D from C. Join C with D. If I join C with D, then this is radius of D. And as per law of parallelogram, or as per Pythagoras theorem, it is 2 square plus 2 square. Therefore, radius of D will be 2 root 2. Radius of D will be 2 root 2. And perpendicular to this radius, rotating in clockwise direction with angular velocity omega. Rotating with clockwise direction with angular velocity omega and perpendicular to this radius, there will be a velocity of point D like this. There must be a 90-degree angle. There must be a 90-degree angle, which is nothing but RD omega. And RD is nothing but 2 root 2, omega is 3, which is 6 root 2 meter per second. 6 root 2 meters per second with this direction, with given direction. Right. Now let us go for point E. Let us go for point E. Here I am erasing everything. Point E. Here, there is a C point here. The C point is rotating with clockwise direction with angular velocity omega, and E is topmost point. Therefore, distance between C and E, this is E point. Distance between C and E will be RE, which is nothing but 4. देख लो diagram. 2 plus 2. Radius of wheel कितना था? 2 meter. Then diameter of wheel will be 4. And perpendicular to this in clockwise direction. In clockwise direction with angular velocity perpendicular to this radius, there will be a velocity of E. Velocity of E perpendicular to radius, which is nothing but RE into omega. Therefore, velocity of E will be equal to RE is 4, omega is 3 angular radian in rad, which is nothing but 12 meter per second. देखो डायरेक्शन भी वही आ रहा है, आंसर भी वही आ रहा है. The same direction with same answer, right? Now, you students calculate for point P, calculate for point P and point R, and write your answer in comment. अब आपके लिए क्वेश्चन find for point P and point R and कमेंट मी योर आंसर। सो अभी इस लेक्चर को यहीं पे कंक्लूड करने जा रहा हूं मैं, बिकॉज मेनी स्टूडेंट्स आर फीलिंग स्लीपी। बहुत सारे स्टूडेंट लाइव से जा रहे हैं, लेट हो गया बहुत ज्यादा, तो लेक्चर को यहीं पे कंक्लूड करते हैं हम। सॉल्व फॉर पॉइंट पी एंड पॉइंट आर आपके पास है क्वेश्चन में, पी वेलोसिटी ऑफ पी एंड वेलोसिटी ऑफ आर, एंड कमेंट में जरूर बताना वही आंसर आ रहा है कि नहीं। चलो तो लेक्चर को कंक्लूड करता हूं मैं यहीं पे। सी अभी तक किसी ने ईकेडा का सब्सक्रिप्शन नहीं लिया है तो सब्सक्रिप्शन फटाफट से ले लो। अगर आपने WADNE 10 ये प्रोमो कोड यूज किया, then you will get 10% discount. Then you will get 10% discount for your subscription. Okay, if anybody having doubt, ask me. Otherwise, I'm going offline. Chalo, bye bye students. Take care. All the best.